All right, you guys, here it is, the moment you've all been waiting for, the last e-learning lesson. You guys have done so great. I'm so proud of all the work that you've been doing. And I know that you are excited to be done and hopefully get back in the building next August. All right, so the last thing we are going to talk about is the volume of pyramids and cones. Okay, and so again, I'm gonna attach a couple videos to the Canvas page that show almost like a demonstration of this that I would have done in class had we been there, but I'm not gonna do it now. All right, and so when you're looking again for the volume, remember you're essentially thinking like, if I were to fill this with water, how much water would I be able to fit in that? That's what volume is. So we talked about how the volume of like a prism, for example, so if we had a rectangular prism, we would need to know how big the base is. That would be the area of that base. And then we would keep filling that all the way up until we got to the very top. So we would find the area of the base times how tall it is, and that would tell us how much we could fit in there. And so to find the volume of a pyramid and a cone, we want to think about those similar counterparts. So like a pyramid is more so related to a prism because the base is either like a rectangle or a triangle or something like that. And so what we would do to find the volume is if I took a rectangular prism with the exact same base and the exact same height and fill it with water. And then I were to use, again, a pyramid with the same base and the same height of that prism, you would find that it contains exactly 1/3 of its similar rectangular prism. And so the volume of a pyramid is, again, the area of the base times the height. So just like a rectangular prism, but multiplied by 1/3 or divided by 3. Remember, multiplying by 1/3 is the same as dividing by 3. So sometimes that can get a little bit messy with the 1/3. So if your value is not divisible by 3, in order to get the exact volume, you'll need to practice leaving things as fractions, which we'll look at as we work through some of these problems. So again, the things that you need to know is the area of the base and the height of the pyramid. So unlike surface area, we don't need to know the slant height. We do not need to know the area of the lateral face, but we may need to use that if you're not given the height, using the Pythagorean theorem to find that height. Okay, so if we look at this first example here, that kind of goes over what I was just talking about. So if I want to know how much I can fill this pyramid with, I need to know the area of the base, and we're again assuming that all of our pyramids are regular pyramids. So this would also be 11.2. The base would be a square. And so I know that the area of the base is going to be 11.2 times 11.2, which is going to be 125.44. Okay, so there's the area of our base. What I don't know is the height of the pyramid. I don't really need to know the 17 millimeters. It doesn't have anything to do with what I need to find volume. So what I need to do is use that slant height to make a right triangle with the height of the pyramid and then half of that base right there. So 11.2 divided by 2 is 5.6. Okay, And so when I go to find this side, I'm going to use, again, the Pythagorean theorem. Sorry, this work is kind of all over the place. So a squared plus b squared equals c squared. 17 squared minus 5.6 squared is going to be 257.64, and I am guessing that is not a perfect square. It's definitely not. So I am just going to leave that as a radical. I would not expect you guys to simplify a radical that contains a decimal like that. It can be done if you change that decimal to a fraction and then simplify the numerator and denominator, but we're not gonna get to that point. So I'm just gonna leave that as the height. So now when I go to find my volume, it's gonna be 1/3 times the area of the base times the height of the pyramid. Okay, so honestly, you guys, I would just leave that as your exact answer. That decimal and that radical, you're not going to really be able to simplify that. So now what we're going to do is find the approximate answer, because I want to know what this value actually is. So the most important thing for this lesson is how you type, well, I shouldn't say the most important thing, but calculation-wise, the most important thing, when you go to type 1/3 in your calculator, you have to remember to put it in parentheses. If you don't, your calculator will do order of operations, which sometimes won't make a difference, but depending on the order that you type everything in, your calculator might multiply by 3 right here before dividing the 1 by the 3. So again, always make sure you put that 1/3 in parentheses. And then from there, you just type everything in. 1/3 times the area of your base times the height. So the approximate answer here is going to be about 671.2. And then since we're talking about volume, our units are always cubed. Okay. So this is like worst case scenario. We get the worst one out of the way here. We've got decimals, we've got radicals, we've got the whole kit and caboodle. But the process is going to be the same for all of these problems. Okay. All right, so now let's look at this next one here. And we need the area of the base times the height. So when I look at that, I kind of breathe a little sigh of relief because I can find the area of the base and I'm given the height. So there is 0 extra work that we have to do. We just have to plug everything in. So 1/3, the area of the base is going to be 5 times 5. The height is 4. Okay, so the first thing you want to do on your calculator is if I type in 1/3 times 5 times 5 times 4, I get that repeating decimal. Okay, so that means that the 5 times 5 times 4 is not divisible by 3. We want, though, the exact and approximate answer. This is going to be the approximate answer, because we can't write that decimal as an exact decimal. It's not like 25.4 done, right? So what you want to do to get the exact answer is, now I'm just going to take the whole numbers, 5 times 5 times 4, that's 100, and then you'll just write that over 3. That's, remember, multiplying by 1/3 is the same as dividing by 3. So that's how you would get your exact answer if, when you type it in the first time, you don't get a whole number or a non-repeating decimal. And then again, for our approximate answer, then we can do 33.3 centimeters cubed. So that would be exact, that would be approximate. All right, so for this one, now we're a little bit different because the base is not a square. It is going to be a triangle. And since we are only using regular polygons, it's going to be an equilateral triangle. So my volume, again, I need 1/3. Now the area of the base is not going to be length times width. It's going to be 1/2 times the length of the base times the height of the base times the height of your pyramid. So I'm going to put that little sub P there so I know that these H's represent two different things. Okay, so I drew my base out separately here. So I'm going to find the area of that. So 1/2 times the base. Now I don't know the height, but because this is equilateral, that means that this is a special right triangle. This is going to be a 60-degree angle right here. That's going to be a 30-degree angle right here. And so if the length of the side is 14, this is going to be half of that. This is always radical 3 times as long. That's going to be the case for every single equilateral triangle that you're trying to find the height of. So 1/2 times 14 times 7 is 49. Okay, so that's the area of the triangle. So now I don't need to find the height of the pyramid. That's this right here. And so now when I go to substitute everything in, I'm going to do 1/3. The area of the base was 49 radical 3, and the height was 18. I'm going to do the exact same thing I did in number 2. I'm going to multiply all of the new non-radicals together, see if I get a whole number. If I don't, then I'll just multiply the 49 and the 18, put that over 3, and then tack on the radical 3 at the end. Okay, so parentheses 1/3 times 49 times 18, we get a whole number. Okay. And you can tell actually too, since 18 is divisible by 3, it's going to work out. 25 is not divisible by 3, 4 is not divisible by 3, so that's why that one doesn't work. All right, so then this final answer is going to be 294 times the square root of 3 inches cubed. And then when I go to find my approximate answer, 294 times the square root of 3 is 509.2 inches cubed. Okay? And so that is the volume of a pyramid. Again, the kind of tricky scenarios will come in if you don't know the height of the pyramid, and you'll have to use the Pythagorean theorem to do that, or if your base is an equilateral triangle using special right triangles to get the height to get the area. Okay? All right, so now we're going to look at cones, and they are very, very similar. Okay, a cone is related to a cylinder because the base of a cone is a circle. And so if I were to take a cylinder and a cone and put them side by side, and the cone and the cylinder have the exact same base and the exact same height, if I were to fill both of them with liquid, the amount of water in the cone would be 1/3 of what it is in the cylinder. So the formula for volume is still 1/3 times the area of the base times the height, just like a pyramid. The only difference is we can kind of break this down even more, because the base of a cone is always going to be a circle. The base of a pyramid is not always going to be a square, so we can't specify what that area is in a pyramid. So I can rewrite this as 1/3 the area of the circle is pi r squared times h. That's going to be our formula. Okay. So again, we need to know the radius, we need to know the height. If you don't know either of those things, then you'll use the Pythagorean theorem to find it. And so that's going to be the case in number 1 right here. So I don't know the height of the cone. I know the slant height of the cone. And so the first thing I'm going to do is find that value. So a squared plus b squared equals c squared. 36 minus 16 is 20. And so then I'll take the square root of both sides. When I go to simplify that, 4 is a perfect square that goes into 20. And so that's going to simplify to 2 radical 5. Okay, so that's going to be the height. I know the radius, so from there I'm good to go. So this is going to be 1/3 times pi times r squared times h. Okay. And I can already tell that this is going to be a little bit of a messier exact answer because 4 squared is 16. 16 is not divisible by 3. 2 is the number out here. It's not divisible by 3 either. And so I'm not going to get a whole number when I multiply the 1/3, the 4 squared, and the 2 together. So again, I'll just start by multiplying 4 squared times 2 and then putting that over 3. So 16 times 2 is 32 over 3. And then the pi and the radical 5 can either go in the numerator or you can write it kind of next to the fraction like that. But that would be our exact answer. The numerical values are 1/3 times 4 squared times 2, which is the 32 radical 3, times pi times the square root of 5. Okay, and so now to find our approximate answer, I'll put that 32 over 3 in parentheses. Anytime you have a fraction, whether it's 1/3 or not, put it in parentheses, times 3.14 times the square root of 5, we're going to get 74.9. And then inches cubed. I'll put my right there too. Okay. All right, and so then in number 2, again, we need the area of the base, we need the height. I need to know the radius to know the area of the base, so luckily all I have to do here is divide that in half. So the radius is going to be 5.75. From here now though, I'm good to go. I don't need to do the Pythagorean theorem. You don't need to know slant height to find the volume. So it's going to be 1/3 times pi times r squared times h. All right, so most likely this is not going to be divisible by 3, but we'll check it out. So 1/3 times 5.75 squared times 15.2. Let's see if that gives me something nice. It doesn't. So I'm just going to multiply the 5.75 squared times 15.2 over 3. And then multiply that by pi. And that would be our exact answer. And so now I'll find my approximate answer. So 502.55 divided by 3, and then multiply that by 3.14. So that's actually going to just round to 526 centimeters cubed. Okay. All right, and so the last example we're going to look at is a composite figure. So remember, a composite figure is when you have like two 3D figures kind of on top of each other. And so for surface area, remember, we kind of had to make up our own formula because surface area is only like what you would wrap. So we would only wrap like the outer part of this and the outer part of this and one base. So we would get rid of the pi r squared from the surface area of a cone, and we would get rid of one of the bases for surface area of a cylinder. But for volume, it's different. It's essentially saying if I fill this with water and this with water, how much water will be in there, okay? So for this, you really just have to find the volume of each figure, and then you'll add them together. So if I write this formula off to the side, so the volume of the cone is 1/3 pi r squared times h, and I'm gonna again put a little c here so I know I'm talking about the height, not the volume, the height of the cone. I guess cone and cylinder start with the same letter, so I'll actually write the word cone there. And then the formula for the volume of a cylinder is pi r squared, and then we'll need the height of the cylinder. Okay, now because this is a composite figure, the radius for both the cone and the cylinder will be the same because they overlap with each other. So since the diameter is 12, the radius is 6. So then when I go to look at what else I would need, I need the height of the cone and I need the height of the cylinder. Well, I know the height of the cylinder is 38 inches, but I don't know the height of the cone. So if I draw a little right triangle right here, again, I know that that's 6. So off to the side, I'll do a squared plus 6 squared equals 10 squared. 100 minus 36, oh good, this one's gonna work out, is 64, and then square root each side, and we get the height of the cone to be 8 inches. So from here, we're off. And so it's gonna be 1/3 times pi times 6 squared times 8 plus pi times r squared times 38. Now, luckily I see that that's going to be 36, and 36 is divisible by 3, so this is going to work out. So this part's going to be 96 pi, and 6 squared, 36 times 38 is going to be 1,368 pi. So then when I add those two together, I get 1,464 pi inches cubed. So when I find my approximate answer then, that'll be 4,596.96 inches cubed. Okay, and that is it. Last lesson of the school year. As always, if you guys have any questions, please reach out and let me know. Tomorrow you'll be reviewing, and then we will end with a test on Thursday. Have a great day, guys.